Now, the human brain, and that's located in the head, you know, somewhere, sees only one octave of color. But even with our little color octave here, we can mix 10 million different shades. And I ought to know because I counted every one of them just before the program. Now, for a little color harmony. For the first time on TV, Bon Drake will play for you in color. I call it a spectrum song, because it's about that. So now we're going to do the song for you. Red, yellow, green, red, blue, 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 red, purple, green, yellow, orange, red, 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 yellow, green, red, blue, 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 red, purple, green, yellow, orange, red, red. Blend them up and what do you get? Cerise, chartreuse and aqua, mauve, beige and ultramarine and every color in between. Yes, Canova, something, bow wow, color has its harmony. And just like I have said, red, yellow, green, red, blue, 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 red, purple, green, yellow, blue, purple. Purple, wait a second, what am I saying? It's supposed to finish with the red. Red.
So what is an electromagnetic wave? An electromagnetic wave is a transverse wave consisting of oscillating electric and magnetic fields at right angles to each other. So, easy words. Electromagnetic waves, they are a transverse wave. No medium required. They are radiant energy, or you can say light waves, both visible and not visible to humans. They can travel through a vacuum, in other words, space. And they're all created by vibrating electrons. Electromagnetic waves are light waves. They are a transverse wave. Remember, transverse waves look like this. There's no medium required. They give out radiant energy, otherwise light. You know, when you feel a light bulb get warm, that's a radiant energy. They can travel through a vacuum, which means they can travel through space, and they're created by vibrating the electrons, which is why they don't need the medium. Okay, so when we have the electromagnetic spectrum, the light waves, we have a huge range of electromagnetic waves. We have waves that we can see, and we have waves that we can't see. We have waves right in the middle that we can see. That is the visible spectrum. So because we have such a huge range, we have this mnemonic that helps us remember our electromagnetic spectrum. The mnemonic says, red Martians invaded Venus using X-ray guns. So each letter is going to represent a letter from what we're trying to remember. So red stands for radio waves. Martians stands for microwaves. Invaded stands for infrared. Venus stands for visible. Using stands for ultraviolet. X-ray actually stands for X-ray. And gun stands for gamma rays. So in the spectrum, your radio waves are going to be your longest waves. It means your gamma waves are going to be your smallest waves, which means the only ones we can see are right here, and the visible. And in the visible range, there's only a certain amount that we can see. So we have a mnemonic for helping us remember visible light. Roy G. Biv. And there used to be an I in there for Biv, but indigo doesn't really exist. So it's just Roy G. Biv with a BV. So even in the visible light range, we have longer wavelengths and shorter wavelengths. So your red light has the longer wavelength than your violet light does. So in the visible light spectrum, red light has the longest wavelengths and violet has the shortest wavelengths in our visible spectrum. So the frequency of red light runs around 400 hertz and the wavelength is about 750 nanometers. Whereas on violet light, the frequency is 750 and the wavelength is about 400 nanometers, which, if you think about, means that red is low energy, whereas the violet light is a higher energy. Now, all electromagnetic waves travel at the same speed. They travel at the speed of light. So the speed of light in a vacuum is 3 times 10 to the 8th meters per second, which, if you think about it, is the same as velocity, which means that we can use the velocity is equal to frequency times wavelength, or lambda, is going to be exactly the same as saying light is equal to frequency lambda, and then you can replace this for your c. When we're working at this, we can put this into our triangles. Since the speed of light is always going to be 3 times 10 to the 8th, you can go ahead and plug that in, or you can plug in the letter C in your triangle, frequency, and wavelength. Just remember that you can put 3 times 10 to the 8th in for C, and then utilize your triangles. Now, just a couple little fun facts. So the speed of light in a vacuum is always designated as c. This equation from Einstein, E equals mc squared, that is exactly what he is talking about. He is talking about the speed of light squared. So if we break down the speed of light into other terms, it's 3 times 10 to the 8th, which is also equal to 186,000 miles per second, which is also equal to 1.08 billion kilometers per hour, or 671 million miles per hour. Little food for thought. Astronauts then travel at 18,000 miles per hour, or 5 miles per second. A beam of light could travel around the Earth 7.5 times in 1 second. Pretty cool, huh? All right, what I'd like for you to do is to find somebody in your class, whether they're across the room or whatever, and I'd like for you to explain to them what the electromagnetic spectrum encompasses. What makes up the electromagnetic spectrum? Thanks. Have a great day.